Find the volume of the solid of revolution formed by revolving the region bounded by the graph of x equals e to the negative y squared and the y-axis between 0 and 1 about the x-axis. So first of all, about the x-axis, the first thing I'm going to do is mark that. Now I'm going to put in the bounds. It says the y-axis, as long as 0 is less than or equal to y, is less than or equal to 1. So what that does is it creates this region right here, 0 to 1. Now the graph of x equals e to the negative y squared. Obviously this equation is already in terms of y. So I'm going to want to try to set up a representative rectangle that uses a delta y or a dy, which in this section means I'm using the shell method, right? That's kind of the point of the section so far. But because of the fact that this is what I want you guys to realize, the equation is written in terms of y, which means I want to make a horizontal representative rectangle so that I have a delta y. That way I don't have to rewrite the equation. That's the important thing. Now because of the fact that I'm revolving about the x-axis, and I have a representative rectangle that's parallel to the axis of revolution, this tells me I need a shell method set up. Okay? Notice that if we slide this representative rectangle all the way to the top and all the way back down to the bottom, it doesn't have any corners or any other little weird features that make it have to switch functions, which is also important. It simplifies the problem. So, now all I have to do is develop two functions to multiply together. What are my two functions? P and H. Yeah, P of y is the position of the representative rectangle. So this is my P of y. Where is the representative rectangle in relation to the axis of revolution? Y. Because. How far away is the representative rectangle away from the axis of revolution? It's y away, however high that is. Okay, the other thing is h of y, which represents what? The height of the representative rectangle, which in this case is going to be that right there. So this is my h of y. What is that going to be? Just the function. Normally it's the right function minus the left, but the left is just the y-axis, which is 0. So we just have our function. H of y equals e to the negative y squared. So we're probably ready to go. The shell method says v equals what? 2 pi. 0 to 1. P of y times h of y, so y times e to the negative y squared. And then dy, the width of the rectangle. So that's the setup. How do we integrate that? Okay, so u is going to be what? Okay. Good. Right, we have a y dy here, so solve for y dy, and that gives me negative 1/2 du equals y dy. So what do we have then? Two pi times negative 1/2, so it's just negative pi, that's right. Integral from 0 to 1 still. E to the u, is that what you're mumbling to me? E to the u du. All right, so v equals negative pi times e to the negative y squared from 0 to 1. Okay. So v equals That's a good question. So this is a negative what? No. It's a negative 1 times y squared. So the order of operations here says when you substitute that 1 in, it's 1 squared, which is 1. But then times negative 1, which is negative 1. So this is actually e to the negative first power, which is 1 over e, minus e to the 0 is 1. Okay, so now I can do kind of like I did on that homework problem the other day, where we can distribute that negative sign in, realizing that 1 over e is smaller than this 1 right here. So if I distribute that negative sign in, that will switch these two, and it'll be 1 minus 1 over e, which is also positive. So I get v equals positive pi times 1 minus 1 over e as the simplest answer. And then if you needed to, or if you wanted to, you could approximate that. We can type that into our calculators. What do we get? .9858, so 1.986. So either of those would be your answer. So now we're going to incorporate all of the methods that we know. We could use the shell method, we could use the disk method or the washer method at any given time. It just depends on which one seems like it's going to be the easiest to us. So this is a problem that we did back in the the second section of the chapter when we were learning about the disk method and the washer method. Find the volume of the solid form by revolving the region bounded by the graphs of y equals x squared plus 1. So that's the graph that we have up there right now. Y equals 0 is the x-axis. X equals 0 and x equals 1 are these guys here. So we are forming this region here. And then we're revolving it about the y-axis. So we're going to spin this region about the y-axis to form, I think I was trying to call it like an egg holder or something. So we're making that region again. It's the exact same problem, except now we know all of the methods that are available to us. If you remember when we did it the first time, we had this axis of revolution here, which means that for the disk and the washer method, we had to make a horizontal representative rectangle, which then we try to slide, but it gets caught right here. So we had to split this into two separate integrals. Now let's see if we can do this using the shell method. The shell method with the same axis of revolution is going to give me a parallel representative rectangle. So now my representative rectangle is vertical. If I slide that rectangle from left to right, will it get caught on any corners? No. So in this case, with the shell method, there's only one integral that we need, which is nice. This representative rectangle gives me a delta what? A delta x, which means my function just needs to be in terms of x. Is it? Yes. So now we don't even have to rewrite the function, which is really nice. So all we need is a p and an h. We're using the shell method here. Sometimes it's helpful to write that down. When you guys take your test on the chapter, I'm going to ask you to do that so that I know which method it was that you were attempting. Because sometimes it's not very obvious. Okay, so what do we need? All right, we need a p of x, and that is the position of the slider relative to what? The axis of revolution. It's not an axis that you see. It's not necessarily the y-axis or the x-axis. It's the axis of revolution. If this axis was all the way over here, then we would be making our p of x from where the slider is all the way back over to here. Okay? So keep that in mind. That's a problem that's coming up pretty soon. You'll see. We'll do an example. So this right here, though, is my p of x. What is it? Yeah, it's just x. Okay, so then my other function that I need is the h of x, which is the height of the representative rectangle, which is going to be what? Is just the function. Okay, now what? V equals. Yep. Yep. Slider goes from 0 to 1. Okay. dx. Now, how should we integrate this? I would distribute too. A lot of times you're going to have two functions here that you can either distribute or just FOIL and work with a straight up polynomial. It's going to be easier to do. So I'll just go equals 2 pi integral 0 to 1 x to the third plus x dx. Okay, so we integrate v equals 2 pi times what?
X to the 4
Yep.
plus x squared over 2.
And we're evaluating from 0 to 1. 0 will disappear, so we have v equals 2 pi times
1/4.
and then technically minus 0, but that just disappears. So 1/4 plus 1/2 is 3/4. So we have 2 pi times 3/4, which becomes 3 pi over 2. Units cubed. And that's your answer. So we get the same answer. If you look back in your notes on this problem, we get the exact same answer. Get the same answer both ways. All methods work, always. It just depends on how you have to set it up. So like the last problem, usually one of the three methods is going to be best. The question is, when is a certain method better than another? And that just comes kind of from developing an intuition on these types of problems, or maybe seeing some sort of trick to help you kind of see which one's going to be best here. So we have a pontoon being designed. You guys know what a pontoon is, right? All right, a pontoon is being designed by rotating the graph of this right here between -4 and +4 about the x-axis. So I'll put that mark on there right now, where x and y are measured in feet. Okay, so we're actually given units on this one, so we'll have to remember to include units cubed at the end. Find the volume of the pontoon. Now, it doesn't tell me to use a certain method. We are in the shell method section, but that doesn't mean anymore that we need to use the shell method, okay? We could use the disk. Well, and the washer method is the same as the disk method, just with no hole, right? So it's either disk method or it's shell method, okay? Now, a disk method is going to make me have to create a perpendicular to my axis of revolution representative rectangle, right? A shell method is going to make me have to create a parallel representative rectangle. Which one looks better?
Both would work, so we have a function defined for x.
Okay, so first of all, our function is in terms of x. So we're trying to think of something that's going to give me a delta x. That way I don't have to rewrite anything. But rewriting isn't as big a deal as having two separate integrals that I have to set up. So the slider in this case, my vertical slider, does slide from left to right easily, but so does my horizontal representative rectangle. It slides up and down just as easily. There's no corners that it catches on, okay? So that doesn't really help me. Can I rewrite y equals 1 minus x squared over 16 fairly easily? Yeah, I can do that as well. So it's not that big a deal having to rewrite the thing. There are going to be problems where you won't be able to rewrite it easily. So far, one method isn't really better than the other. I personally am leaning towards the disk method already because of one last little detail. Right. The ends of this representative rectangle are both defined by the same function. That can be a problem. So both ends of this representative rectangle, as it slides, are changing. And because both ends are changing, it makes it a little bit more difficult to define it, especially given that this function is defining both the left and the right side of that representative rectangle. However, if I use the vertical one, then this bottom is staying constant on me, and they're two separate functions basically that are defining the top and the bottom. So I'm going to choose the vertical representative rectangle because it just seems like it's going to be a little bit easier to work with. Okay? So let me get rid of the horizontal one, and we'll just work with that vertical one. Which tells me that I'm using what method? I'm using the disk method. All right, so we got to remember the disk method now. How do we do that? Okay, so you remember the algorithm. What are we doing here? This is the radius, because once I revolve this, it's going to be a disk that's created. So we're creating a radius, and the radius, to make a area of a circle, I have to do pi r squared. So that's where the pi is coming from up front. Integral from what to what? -4 to +4, that's where my slider goes. Now I need r squared times the height of that representative, or the delta x, the width of that representative rectangle. So we have what? Squared dx. And that's because the height of this representative rectangle is my capital R of x. It turns into the radius of the disk, and that is just my function that I'm given right here. So now what should we do? You're probably thinking of some other four-letter F word, but we should probably FOIL it. You want to FOIL this. It's going to be ugly kind of, but you want to FOIL this. That's going to be the easiest way to handle a problem like that. So we have v equals pi integral -4 to 4, and we got to FOIL. So what do we get? I'll do the hard part. 1. Minus x squared over 16, minus x squared over 16, so that becomes minus 2x squared over 16. Minus x squared over 8. That takes care of the O and the I and the L. Positive. X to the 4th over 16 times 16. 256. dx. All right, now what? No. You got this far. You might as well integrate it. V equals pi times x. Okay. Okay. Plus x to the 5th Come on, 256 times 5. That's easy. No. 1280. I thought you said 10 something. That's what you said? Man. No. Okay, and we're going from -4 to 4. Sorry. So we get a pi out front times hopefully you're using a calculator here. We got 4 sitting there. X to the third. So 4 to the third is 64. 64 over 24. Bunch of stuff, minus some stuff. Want the exact answer. O is usually a bad sign. No. 64 pi over 15. Probably did. So there's your exact answer, 64 pi over 15, but we are given feet, so this is feet cubed as our answer. That's the exact answer, and the decimal approximation of that would be like 13.4 or something feet to the third. Okay, let's draw in the bounds here. What should I draw probably? What is y equals 1? A line, good. A horizontal line. What about x equals 1? A vertical line. So we have y equals 1 is this guy, x equals 1 is this guy, and then I have the function, so I'm basically looking at this region right here. Now, what are we revolving around? X equals 2, which is a vertical line. So I showed you center lines would be a long dash and then a short dash. So I'm drawing in my center line like that. All right, so here is my object or my cross section that I'm revolving about this line right here. It is not on an axis this time. So anything else I should put on there? Yeah, I got to figure out a representative rectangle. Before I do that, I want to figure out which method is going to be best. So are there any methods that we can't use? Disk method is out because we're going to have a hole here for sure. So you could set up a washer method, or you could set up a shell. Why shell? Because shell is easier? Not always. What did you say? Because this is the shell method section. No. So you can use either the shell method or the washer method on this one. With this axis of revolution here, the shell method would give me a representative rectangle that's parallel to that. So this would be my representative rectangle. The washer method would give me a representative rectangle that is perpendicular to that. So this would be my representative rectangle. In this case, with the washer method, I'd need a delta y. We're already in terms of x here. So the better option is going to be that representative rectangle. Now, in addition to that, when you look at this function, are you going to want to solve that for x? Are you even able to solve that for x? No, we're not. We're not able to solve this one for x. So that also is a clue that you're not going to be able to use the washer method. So this guy right here is out. We're going to have to set up a shell on this one. All right? Okay, and even if you could solve this one, why would you want to? You can set up a shell method just as easily on this. Okay, so what are the two things we need for a shell method problem? We need P of x and H of x. So let me stay with red, I guess. Now, P of x is what? The position of the slider relative to... So therefore, if this is my slider, then this distance right here is P of x. Would it be 2 minus x?
No. 2 is something.
So think about where the slider can go. It can slide all the way over to here, which is how far away from the axis of revolution? 2. Now I can slide it all the way back over here, and then that's it, right? But if I could slide this all the way back over here, how far from the axis of revolution would that be? 0. So I need to be able to slide this from 2 all the way back to 1. So I need to come up with numbers that are going to give me that, okay? Now, how far is this slider away from the x-axis right now? It's x away from the x-axis, right? When the slider is all the way over here, how far away is it from our axis of revolution? It's 2 away. How far away is it from the x-axis? 0 away. What is more important? How far away it is from the x-axis, or how far away it is from the axis of revolution? Axis of revolution. So, how would I calculate where this thing is relative to this? Well, the answer is, if the slider is all the way over here, then it's 2 away. As it slides back, it has slid back how far? It slid back x, which means I need to remove a distance of x from 2 in order to get where it's at. 2 minus x.
I feel like Bono. I said that.
You did say that, but I'm not just going to say, yes, you're right. And so we have to explain why that is 2 minus x, okay? It does take a little bit of extra thought setting up the P of x, the position in terms of x, from the axis of revolution when the axis is not on an x or a y axis. So always go as far away as you can, figure out that distance, and then subtract off, or add 2, depending on where that axis is. Okay? All right, so we have P of x equals 2 minus x. I guess I didn't need parentheses there. But now we need h of x. What is h of x going to be? The function what? Minus 1. Why are you saying that? Okay, good. So normally if we're coming all the way back down to here, it would just be the function. But it's not just the function. We don't want to include all of this area down here in our representative rectangle. So that means we do take the function to give us this whole representative rectangle here, but now we've got to subtract off this chunk right here. This chunk right here is always 1, defined by that y equals 1 horizontal line. So that means that my h of x is going to be the top function, which was x to the third plus x plus 1, minus the bottom function, which was just 1. And then we can simplify that. We get x to the third plus x, and that's it. So, now what can we do? Set up the integral, yeah. V equals what? It's the shell method, so it's 2 pi. Integral from
We need to take the y equals 1 on bound, solve for where the x is at.
We're just going from 0 to 1.
But how do we know it's 0?
How do we know where 0 is? On this guy, you mean? Well, that looks like the y-intercept to me, right? So take a look up here. If I plug 0 in for x, I get 1 for y, which is exactly what I thought it would be. So we're crossing this line at 0, 1. So we're going from 0 to 1. Remember that the bounds are where the slider can go. It can go from over here to over here. That's from 0 to 1 on the x-axis. 0 to 1. And now what? P of x times h of x. So we have 2 minus x times x to the third plus x, and then the width of our representative rectangle, so delta x. Now what should we do? Definitely. You want to FOIL that. So v equals 2 pi integral 0 to 1 of what? I'm hearing mumbles. You guys agree? Okay. So now we should be ready to integrate, right? V equals 2 pi times. Whoa. I'm just going to go in order up here. This becomes x to the fourth divided by 4, but that's 2 over 4, which reduces to x to the fourth over 2, plus so it just reduces to x squared, minus x to the fifth over 5, minus x to the third over 3. All of that is going from 0 to 1. Nice thing about that lower bound is all of those go away, so we can probably do this in our heads. V equals 2 pi times 1/2 plus 1 minus a fifth minus 1/3. And then technically minus a bunch of zeros. Common denominator here would be 30. Sure. So we got 15 plus 30 is 45 minus 6, so we're at 39. And then we have minus 10, so we're at 29 thirtieths times 2 pi, 29 pi over 15. No units, so it's just units cubed. That's it.